Okay, so for this video, I'm going to talk to you about Unit 6, Day 11, Lesson 5B, Building Quadratic Functions to Describe Situations, Part 1. And in this video, we're going to focus on the warm-up activity for this lesson, which is utilizing the 3 reads strategy to give students a deeper understanding of this problem. So before I jump into actually showing you how you can execute this, I'm going to show you on this slideshow where you can access resources for the 3 reads. So if you notice in this slideshow, you have multiple slides that kind of pull out some important resources. This slide here gives you some detailed explanations on how to utilize the 3 read strategy and the rationale behind it. And then there is a template on slide 6 that you can use that gives you kind of a Google Slides deck that models this strategy. I use this template as a starting off resource to create a Desmos activity that students can use while I'm executing the 3 read strategy. And this is for a synchronous lesson. So if you go to, right here I have a Desmos activity. Typically the way Desmos works is you assign this to students and then students will work on the activity while you get to track their progress. And so we'll go through a model of how you could execute this in a class. So the lesson goal and the goal of utilizing the 3 read strategies is for students to learn to read like a mathematician and pay attention to quantities in the problem statement. And so this little mini kind of beginning lesson is going to center around giving students these tools. And so I would be either sharing my screen with students, while I'm going over this part of the kind of going over the rationale behind the activity. And a cool feature about Desmos is you can restrict what screen students are viewing. So I would only let them view slides 1 and 2 during this time. And I would also review this slide, kind of going over what the routine is going to look like. For the 3 reads routine for our warm-up today, we're going to first read the problem and ask ourselves, what is it about? Then we're going to read it again together, and we're going to ask ourselves, what are the quantities and the relationships within the problem? And then the third time we read the problem, we're going to ask ourselves what mathematical questions we could ask about the problem. So now within the pacing, I would release it so students can just see slide 3. And on this first read, we're asking ourselves, what is the problem about? By restricting the screen, students aren't able to jump ahead. And if you notice in this example, first slide of the problem, I took out the actual numbers. We don't want students jumping ahead to solving. We want them to actually start just asking, what is the problem about? And so on this first read, I would go ahead and read the problem to the class while they also have it viewable on their end. Galileo Galilei, an Italian scientist, and other medieval scholars studied the motion of free-falling objects. The law they discovered can be expressed by an equation which gives the distance fallen in feet d as a function of time t in seconds. An object is dropped from a height. Okay, so we don't have the quantities here, and that's the point. We just want students to answer the sentence starter the story is about. And so you might give students a minute or two to go ahead and type into the chat, into their boxes. And so a student might say, the story is about a scientist who discovers a rule to calculate the distance of a falling object as a function of time t. You might have somebody else just write the story is about a scientist. You might have somebody start thinking the story is about gravity. Maybe somebody would write that. We don't know, but that is going to come into play, right? So there's not necessarily a wrong answer here, but we really want to get into the fact that this is a story about a scientist who's discovering an equation, a rule of function that's allowing us to calculate the distance as a function of the time t of an object that's falling, okay? And so when students submit their answers, they can press submit, and all of the answers will populate. So if you had multiple responses, they would all pop up here. And students then can, if they just wrote about a scientist, they can be like, oh, somebody wrote something a little more specific. Let me edit my response and add to it. And so at this point, because students are able to view one another's responses, we would then kind of take a minute, tell everyone to look at their responses, and you can on Desmos highlight specific responses for the class to view. After this read, we're going to paste the activity so that students are now able to access the second read. And now we notice that there's actually the quantities in here. And so we'll read it together, and students are going to answer what are the important quantities, what are the quantities and important relationships in this problem. So Galileo Galilei, an Italian scientist, and other medieval scholars studied the motion of free-falling objects. The law they discovered can be expressed by the equation d equals 16t squared, which gives the distance fallen in feet d as a function of time t in seconds. An object is dropped from a height of 576 feet. So now we might say, okay, everyone take a minute to go ahead and answer this question independently. What are the quantities and what are the relationships? So somebody might say 576 feet. Somebody might say distance fallen in feet, d, time in seconds, t. We also have, some people might notice, like, what is a height? Let's add a height of 576 feet. Somebody might ask themselves, when does it hit, like, the ground is a quantity, right? Because the value of the ground when it hits the ground is one of the quantities in here. Somebody might say that, somebody might not. Somebody might say the 16 in the equation is a quantity. And then, what does that mean, right? That's something that we're all wondering, that we're going to wonder about throughout the activity today. Somebody might say, we don't know, maybe not, but somebody might say gravity. The value of gravity is a quantity here because something's falling and gravity is going to be pulling the object down, right? And so we don't know what we're going to get in answers, but we're going to welcome all responses that make sense and apply to the problem. And again, this will share with the class, and the other responses would show up down here. You can opt not to share with the class for any of these, and you can wait until you share whole group on your screen for everyone to view all of the responses at once. If you want students to not have a chance to view each other's before the conversation. Okay. And then, after they have this option to do a second read, we're now going to go to the third read. And for the third read, we're asking ourselves what mathematical questions we could ask about this situation. So we would go ahead and we would read this one more time. And we would have students go ahead, and at this point it might be really useful to have students actually go into breakout rooms, because this is really the getting into a deeper part of the mathematics, and we want students to be able to make that connection. When we have this type of problem, we want to know when it hits the ground. At what time is the object hitting the ground? And so students can go into breakout rooms for a minute or two and go and discuss the answer to this question and come up with an agreement together. You might ask them, don't type your response into the box yet. Come up with an agreement together and we'll share out as a whole group in the main room. You might pop into breakout rooms, push the conversation, even maybe giving a visual model, actually showing on the Zoom video, here's an object, I'm dropping it. What might you wonder? What might somebody want to know about that object dropping? And getting to that point that we want to know how long does it take for the object, to hit the ground. Okay? And so we come back together. You might, prompt a group when you're in breakout rooms. Oh, I'm going to have you share out. They share out. You might ask if anyone came up with any other questions. We welcome all questions, but this is the key question we want students to answer. And that's because when we get to this activity, when we get to slide 14 after this to the Explorer, we're really going to see students analyzing this problem in two different tables, noticing how here we're starting at 0, 0, and here we're starting at 0, 576, and that's going to get to the root of our discussion, our question. Okay. Again, we could share with the class and we would see other responses. And then finally, students have an opportunity to reflect on learning based on this experience. They can answer any one of these prompts. Maybe you give them a minute or two just to reflect on this experience. You can add the rest of the lesson into Desmos, and this is actually editable on your end. So I'll share this link in the in the video, and you'll be able to access this created 3 reads template. Okay, thank you.